Hi, my name is Zach, and today I'm going to be talking about Burma and tungsten. Burma is also known as Myanmar and is located in Southeast Asia. As of 2005, the capital is Naypyidaw, and in 1948 it became an independent democracy with a free market economy. There are over 55 million people and over 135 ethnicities, but only 7 primary ones, and these make up the 7 administrative states. There are about 60 languages spoken, but Burmese is the primary language. 88% of the people are Buddhist, but there is no official religion, and due to the high prominence of Buddhism, there are pagodas located all over the country. One specific pagoda is the Shwedagon Pagoda, which is said to contain Buddha's hair. It is entirely covered in gold leaf and contains nearly 5,000 diamonds. The Multi Mine is an underground mine that was opened in 1910 and is a great source of tungsten, which comes from scheelite and wolframite. In the 1930s, it was the most important source of tungsten in the world, but after World War II, it declined in use because parts were destroyed. In 2015, there was a landslide nearby that caused the mine to close for about a week. Tungsten is a transition metal with the chemical symbol W, atomic number of 74, and atomic weight of roughly 184 grams per mole. It has the highest melting point and tensile strength of any pure element. It is electrically conductive, thermally resistant, and resistant to acids, bases, and oxidation under normal conditions. In 1761, John Lehman discovered that there was a new element in wolframite, but he didn't know what it was. In 1781, Carl Skeel isolated tungstic acid from scheelite, which comes in both yellow and white forms. In 1783, 2 Spanish brothers finally produced pure tungsten metal. Tungsten is strong alone, but it's even stronger in compounds, such as tungsten carbide, which is used to harden saw blades and drill bits. There are 2 primary reactions which we will explore further. Tungsten hexachloride, hydrogen gas, and methane form tungsten carbide and hydrochloric acid at 943 Kelvin. Delta G is negative, and the delta H and delta S are positive, which indicates that this reaction is endothermic and spontaneous at this temperature. Here, tungsten hexafluoride, hydrogen gas, and methanol form tungsten carbide, hydrofluoric acid, and water at 623 Kelvin. Delta G is negative, and the delta H and delta S are positive, which indicates that this reaction is endothermic and spontaneous at this temperature. Another really strong compound is tungsten disulfide, which is used as a dry lubricant at very high temperatures. There is no reaction of formation because this occurs naturally as tungstenite. Due to its high heat resistance, tungsten is used in heating filaments, spacecraft applications, and lighting filaments. Some bacteria even have enzymes that use tungsten to reduce carboxylic acids to aldehydes, such as formal FMR dehydrogenase. Since it is essential for life, it is not considered to be hazardous and is the heaviest element to play a role in life. A few fun facts. There are 5 naturally occurring isotopes considered stable due to their extremely long half-lives. The density of tungsten is extremely close to gold's, and diamonds are the only material that can cut some alloys. Here are my references, and thanks for watching.